welcome to this episode of our study of linear algebra. So in this, I'm gonna show how to use a technique called Gaussian elimination to solve systems of equation. All right, so let's go through some few points I will need. So before you solve systems of equation, we learned in our previous lesson that you can get something called an augmented matrix out of that system, and when you get it, what you're going to do is consider the first row. Maybe if I have my first rows having some values here, maybe some value here, some value here, and the first non-zero, that's the first point. First non-zero should be a 1. Okay, so that is the whole idea we're going to do here. We must make sure that it looks like a 1 or it has a 1 there. If there's no 1, then we do something to that row to have the first non-zero value to be a 1. We go again and then perform our elementary row operations on them to make sure that every value beneath the 1 is 0. Go to the next one, and then the first non-zero value there should also be a 1. So you should have like 1 at the diagonals after reducing it, right? If there are any rows that consist of entirely of zeros, put that row at the bottom of the matrix. So if assuming that I have an augmented matrix where I have some values here, some value, and then the second row has only zeros, and then there's some values here which are not 0, and we have to switch these two to make sure that the one with all zeros comes at the bottom of the matrix. Okay, and switch rows if necessary. So we are trying to apply all that we learned in the elementary row operations in here. Now let's pick an example and then try to work through this. Given that I have these systems, this is the first equation, -2x3 plus 7x5 equals 12, and then this to equation 2, I have equation 3, and I should solve for the values of, I should solve for x1 and x2, x3, and then x5. Now here, what I'm going to do is first get my augmented matrix out of this system, which in this case I have 0 x2 in front of that, 0 x1. So you can try to rewrite all the missing pieces in each equation by introducing zeros, so that you understand that the coefficient of x1 in the first equation is 0, that of x2 is 0, and then x3 is 2. I'm going to have x4 to be 0, that there's supposed to be an x4 here because I have 5 of them, and I have 7 to be my x5, and the last part is the 12. So this 12 is what we have there. Now I'm gonna write the same thing for the other one. I have that 10, 6, 12, and then 28. 2, 4, -5, 6, -5, and I'm gonna have -1 here. So I have this as my system of my augmented matrix out of this system. Okay, so what I'm going to do here is to try to perform my elementary row operation on them. But before then, I have to make sure that the first non-zero value in the first row is 1. But in the first row, I have some zeros here, so it means I have to switch some rows in order for me to perform my row reduce or maybe elementary row operation method. Okay, so what you're going to do is rewrite the same augmented matrix here, which was 0, 0, -2, 0, 7, 12, and I have 2, 4, -10, 6, 12, I guess 28, and I have 2, 4, -5, 6, and then -5, -1. So this is my augmented matrix. So what I'm going to do is swap, you can say row, I'm going to swap row 1 and row 2. So my new row 1 will be equal to row 2, the original row 2. So what I'm going to do is this is going to give a different augmented matrix. So I have 2, 4, -10, 6, 12, and then 28. I'm going to have 0, 0, -2, 0, 7, and 12. And so I've switched them. Then I can keep my third row, which is 2, 4, -5, 6, -5, -1. I'm coming to make sure that the first non-zero value I have in the first row is 1, but I have 2 here. So what can I do to 2 so that I'll have 1 there? So what I'm going to do is, the first one is multiply first row by 1/2, right? So I'm going to get a new row 1, which will be equal to 1/2 of our original row 1. Okay, so this will transform and give a 1 to 1/2 of, and a half of 2 is 1, half of 4 is 2, and I'm going to have -5 here, 3, 6, I'm going to get 14. I keep everything as they are. Okay, 2, 4, -5, 6, -5, -1. Alright, so what we are going to do is now look at all the values in the first leading value here, which is 1. Sorry, I'm writing at different places. Make sure I compare it to the rest of the values beneath that and make everything 0. In the second row, that value there is 0, so I don't really touch it. On the other row, here is 2. So what I'm going to do is I'm going to have my new row 3 to transform to, I want here to be 0. -2 row 1 plus our original row 3. And that's going to give us a new augmented matrix. So I have my 1, 2, -5, 3, 6, 14. Keep them like that. 0, 0, -2, 0, 7, 12. And then this will give me 0, right? And then I multiply 2, -2 to this guy. I'm going to get -4, right? I mean, this side. Plus 4, that's also going to give me 0. -2 times -5, that's going to be -2 times -5, that's going to be, well, 10, positive 10, I guess, right? And then I add it to my -5. So if I add positive 10 to -5, I'm going to get 5, right? I'm going to have -2 times this plus 6, and that's going to be 0, because -2 times 3 is going to be -6 plus 6 is 0, and then -2 times 6 is -12 plus -5, and that's going to be -12, I think, or maybe 17. Yeah, sorry. -12 plus -5 is -17, and then -2 times 14, which is -28, plus -5, which is -29. Okay. Now the next thing to do is to look for the first non-zero. When I say non-zero, something that is not 0 in the next row here. In the next row I have this, so the first non-zero value is -2, but it's not 1. So what I'm supposed to do is make sure that that is 1. So our new row 2 that I'm going to get is 1/2, or -1/2 of row 2. I want to get 1, not -1. So if I multiply by -1/2, I'm going to have a new augmented matrix, which is 1, 2, -5, 3, 6, 14, 0, 0, and I'm going to have 1 here, 0, -7/2, and then I'm going to get -6 here, right? I hope that makes sense, because when you do the division of 12 by -2, I'm going to get -6, right? So I go ahead and write everything I have. 0, -17, -29. Right? So what you're going to do is to transform this and make sure that the value beneath 1 is 0. But I have 5. So what I can do is I'm going to have my new row 3 to be equal to -5 row 1 plus row 3. So I'm going to multiply this guy by -5, add it to this, and that will give me 0, right? So that is going to transform to a different one. I think I have to push this to the top. So what I'm going to get is a different how do I call matrix, which is going to be, I have my 1, 2, -5 still, negative 5, 3, 6, 14. Right, so I have my 1, 2, negative 5, 3, 6, 14. And the next thing is to have 0, 0. This is 1, I didn't touch it. Negative 7 over 2, negative 6. And then when I do that operation that I've written here, I'm going to have 0 here. I'm going to have 0. So 0 times negative 5 is still 0 plus 0 is 0. And then I'm going to have negative 7 over 2. So you have negative 7 over 2 times negative 5, which is 35 over 2. Then you add it to negative 17, right? Remember, 35 over 2 is the same as 17 plus 1 half. So plus negative 17, and that's going to give you 1 half, right? So I'm going to have 1 half here. Then negative 5 times negative 6 is going to be positive 30, and then add it to negative 29. That's going to give you a 1, right? So you have 1. And then again, I ask myself if so I go and look for the next leading value in the next row. So what we are doing is try to make sure that, okay, the first leading value here is 1, that is 1, and everything beneath them is 0. Now come to the next leading value, which is 1 half. Although I don't have any other thing beneath that, but I have to make sure that it is 1, right? So that's what I'm going to do. So now a new row 3 that I want to get is 2 times row 3, so that I can get 1 here. That's going to give us a final augmented matrix in this form: 3, 6, 14, 0, 0, 1, 0, negative 7 over 2, negative 6, and I have 0, 0, 0, 0. This is going to give me 1, and this is going to give me 2 if I multiply all of them by 2. So that's what I have. Now, what we're going to do is employ what we call back substitution, right? So what this whole thing means is that I have x1 in this position, x2 in that position, x3 in that position, s4, and then x5. And these are the corresponding side of the right of the systems of equation, the right side of the system of equations. So what this means is that if I come to the last row, normally if you use the back substitution, you have to use the last row. It means I have 0 times x1 plus 0 times x2 plus 0 times x3, x4, and then plus 1 times x5, which is x5 should be 2. That's what the whole thing means. It means all these guys will give me 0, so I mean x5 is actually 2. So what you're going to do is that x5 is 2, so you're going to go to the next step and use x5 equals 2 to solve for any other variable you can have. Alright, so on that next the just above row you have there, in that row you're going to have 0x1, 0x1 here, 0x2, and then plus 1x3 plus 0x4 minus 7 over 2x5 should be negative 6, right? So this is 0x4, those parts will go, so I have x3, let me erase that, x3 minus 7 over 2 into x5, which is 2, should be negative 6. Now I have x3 and minus 7 should be negative 6. That means that x3 is equal to negative 6 plus 7, and that is equal to 1, right? So you have that to be 1. Now, if you go ahead again, x3 is 1, x5 is 2. Now, the other thing I will need is, I know the only left equation I'm supposed to solve for is this one, right? The first row. I'm going to have 1x1 plus 2x2 minus 5x3 plus 3x4 plus 6x5 should be 14. Then I go again and know that, okay, I will notice that x1 will be equal to 14 minus 2x2 plus 5x3 minus 3x4 minus 6x5. So so 14 minus 2x2, which I don't know, but I know x3 to be 1, so I'm going to put it here, which gives me 1. 1 times 5, which is 5, and then minus 3x4, I don't know x4, minus 6 into x5, which is 2, right? So I'll put it there. And now this will summarize to 14. 14 here plus 5, which is 19, and minus 12. So 19 minus 12, what would that be? That's going to be 7, right? And then I add these two, which I don't know them, negative 2x2 minus 3x4. And this means that we have some free variables. If you remember in our previous lesson, since I don't have anything to have x4 and s2, it means x4 and s2 are free, and I can choose them to be any variable at all. So I can choose that x2 should be maybe t, and then x4 should be maybe an s or something, so that in that case then x1 will be equal to 7 minus 2t minus 3s, right? And then I know that my x5 is actually 2, and then x3 is also equal to 1. So this is the solution to the system, and don't forget to subscribe to my channel if you have not subscribed. See you.